Mr. Ranjan, I need zero point 0.1 molar of hydrochloric acid for my EE.
Yeah, sure, why not? I have 1 molar HCl with me. So you know how to make whatever molarity you want?
0.01 molar.
So you know how to go about it?
Yeah.
Okay. Most chemistry students at IB level are expected to be able to make a dilution. A dilution where you're given a 1 mole per dm cube or a 1 molar solution, and you should be able to dilute this to a 0.1 mole per dm cube or a 0.01 mole per dm cube solution. And this was the very question that was posed by the IB examiners in November 2018 in the all-important Section A of Paper 3, which focuses on practical work. And many students had difficulty with this question, which was clear evidence of the fact that students are not familiar with carrying out dilutions or with making of standard solutions. So let's look at this question, which is slightly different from the scenario involving the student, but very similar. 1 mole per dm cube copper sulfate is to be transformed or diluted to make a 0.010 moles per dm cube solution. And you're supposed to identify 2 essential pieces of glassware that you would need. First, let's take care of the calculation. Many students would be familiar with the equation C1V1 is equal to C2V2, and they would try to use this equation. But if you just jump into using this equation, you could get misled. It's better to rationalize what you're asked to do. And what I mean by that is, look at what you're given. You're given a 1 molar solution, and you need to transform that 1 molar solution into a 0.01 molar solution. If you think about this for a while, you'd realize that you're actually diluting this solution by a factor of 100, shifting your decimal point 2 places to the left. It means that if you take a 10 milliliter sample of the 1 molar solution, you need to dilute this by a factor of times 100. In other words, you need to mix this into a large vessel with 1000 milliliters being the final volume. So 990 milliliters of water plus 10 milliliters of the original solution. But if you prefer, you can plug that into this relationship C1V1 is equal to C2V2. And here you would see that your 1 molar solution, when multiplied by 10 milliliters brought into dm cube, would give you 0.01. And over on this side, the 0.01 concentration that you start with has to be made up to 1 liter or 1 dm cube. So as you actually carry out this dilution in the lab though, this 10 would have to go into a vessel that would then be made up to 1 liter. And that would be quite straightforward if you were doing this particular activity involving copper sulfate. You would put in your 10 milliliters into the appropriate piece of glassware, taking it out with the appropriate piece of glassware, and then making up to 1 liter, again using the right glassware. But what is this right glassware? If we were doing copper sulfate, then we could use a pipette like this to take out 10 milliliters of the original 1 mole per dm cube solution and place it into here, and then use distilled water to slowly make the solution up to the graduated mark here in this volumetric flask, bearing in mind that when we get somewhere around the neck, we would cap the vessel, rotate it a few times, make sure everything is dissolved, and then slowly using a dropping pipette add water until the meniscus just touches this graduated mark here on the volumetric flask. But if we had a scenario where we were diluting a solution of acid like we have the student asking for in this video, then you should remember that you always add acid to water and not the other way around. So with this scenario, then you must first fill your volumetric flask to about halfway with water, and then you take your pipette and you extract 10 milliliters of 1 mole per dm cube hydrochloric acid, you slowly introduce that into your volumetric flask, you swirl and you rotate with the cap on, and then slowly you make up to the mark by adding water. This would not be adding water to strong acid, this would be adding water to very dilute acid. And the bulk of the water would have been put in first, and then the acid would be added, with only the remaining bit from the neck up being added to ensure that you do not exceed the mark and you do not affect the accuracy of your dilution. For the question posed in the past exam, these were the answers expected. But if the student's problem in this video were the question, then you would definitely have to include information about the right safety protocols, and that would be always adding acid to water.